The combination of geothermal heat sources with PVT collectors in heat pump systems achieves a variety of benefits. For example, the heat source with the higher temperature is always used throughout the year, which increases the efficiency of the heat pump. The borehole field is used at night in winter because it has a higher temperature. Snow on the panels can also be melted via the thermal circuit of the PVT collectors. When the sun is shining, the PVT collectors can increase the temperature and reduce the load on the borehole field. For a large part of the year, the PVT collectors can even provide all of the necessary environmental heat for the heat pump. In summer, the PVT collectors regenerate the ground, preventing it from cooling down over the years. Because of the regeneration, the borehole field can be more compact, and fewer holes need to be drilled or can be drilled less deeply. The soil around the borehole remains warmer and therefore does not interfere with boreholes on the neighbouring property. In addition, regeneration cools the PVT collectors in summer and increases the solar electricity yield. Passive cooling of the building also remains possible. Here, fluid from the ground is circulated via a heat exchanger to cool down the underfloor heating. At night, the building can also be cooled through the PVT collectors. Various geothermal heat sources are suitable for this combination. The combination of geothermal heat sources with PVT collectors in heat pump systems achieves a variety of benefits, maintaining the efficiency of ground heat sources, downsizing of the ground heat source due to discharge, and active regeneration, cooling the PV modules and increasing the solar electricity yield, passive or active cooling of the building possible. Numerous projects have already successfully combined PVT collectors with geothermal energy sources for even more efficient, emission-free energy generation for heating and cooling.